with the materials. It's desirable. Do you want to put up the materials from there, Valerie, or do you want me to do it from here?
I will do it.
Okay.
So shall we start?
Yes, I'm just trying to figure out how to get onto the online tool. I'm sure I can figure it out all by myself. So yeah, I think you could put up, yeah, I guess you already have up the right slides to start with. So why don't we give it one more minute since people are getting back from lunch, and at this
Okay.
point have, I don't know, there might be, 10 people in the room? So, and it looks like we have 15 people online now, which I think includes people in the room, right? So, I don't know who, I guess Jan Fred's is remote, and, yeah. Do you and Jan Fred are presenting. Do we have any other presenters I should be making sure I have present? Okay, yes. Directly behind your head. Okay, it looks like we've got the usual people, so why don't we start? Do you want to do the chair slides, or you want me to do them?
I will go through the chair slides.
Sounds good.
So, hi everybody. This is RADEXT session at IETF 120. I hope everybody here in the right room. And if you are not in the right room, please make sure you are in the right room. So this is Note well, and it's a usual Note well. It doesn't change recently. So just mind that all the contributions that you have made during this session is subject to IPR from IETF. Note that the session is being recorded. And this is just an advice for conduct. So please respect other people and be polite and so on. The meeting details, so chairs are Margaret Cullen and Valerie Smyslov. Our ID is Paul Wouters, and below are links for slides, Miteco, notes, and we should do some administrative tasks. So we don't need blue sheets, they're collected automatically, but please, those who are on site, log in with the Light client or scan a QR code that must be provided in the entrance of the room, so that the number of people in the session are calculated correctly, and the next time we can get a room of sufficient size. And so we also need 2 note takers. So any volunteers? So I cannot see all the room. So Margaret, please.
Is there anybody who will volunteer to take notes? I don't know your name. I'm sorry. Okay, Jonathan will volunteer. Anybody else want to take backup notes in case Jonathan gets involved in discussion or something? Okay, I'll try to fill in, I guess, if that happens. We
Okay,
also
and
recorded, of
I
course.
can monitor the chat. So in case somebody is unable to send video and want to relay his or her question.
Okay, sounds good.
So, okay, so this is an agenda for today's session, and by request, we just make some changes in the order from the very beginning. So, and the first presentation is for from Nadia for radius blast, and then we will go through the working group documents, and we hope the most time to devote for to uh, TLS and DTLS transport encryption for radius, because this document is very important, and it is close to working group last call, but there are still some issues, so we're going to discuss, or at least enlighten these issues today, and then some short reports for the rest of the working group document. So any agenda button?
Well, I don't see
Okay,
anything here or in the chat, so let's go ahead.
okay, then I think we can start with Nadia's presentation.
Sure, yeah.
How's the camera situation? I'm gonna like,
Usually there's supposed to be a spot marked.
oh, there is, okay. There's an X. I'm gonna like
Yeah.
pull this out. So this will be a joint presentation also with Miro Holler, who is my student who also worked on this. So I guess we
Make
failed
sure
to
you
put that
keep
in
it
the
close to your
schedule.
mouth and you don't
Okay.
turn away from it because people will have trouble
Yes.
hearing.
Okay. And this is joint work with a number of people from a number of different institutions. Okay, I guess next slide. So this presentation is somewhat similar to what we did yesterday in the SAG meeting, but we'll go into more details on the actual attack for those who are interested. So the summary is that Radius is vulnerable to a man-in-the-middle attack, and in particular, such a man-in-the-middle attacker can forge arbitrary radius responses for any authentication mode that does not require message authenticator attributes, and so that includes all non-EAP authentication modes according to the RFCs. And this is a protocol vulnerability in the way that the response authenticator is designed. And the full details of our attack are in a paper that will be published at Usenix Security 2024, and they are online at our website, blastradius.fail. Okay, so next slide. So there is always an XKCD cartoon for anything, any talk about the internet. So this is kind of the one for this talk. And I think everybody in the audience here knows that Radius is everywhere, and it's kind of the standard lightweight protocol for authentication, authorization, and accounting. And it is embedded everywhere in our network infrastructure. And probably I don't need to say too much more for the people who are actually in the audience here. Okay, I will. I guess next slide.
I don't know if this works.
Does that work? I hit a button and it didn't do anything. I hit another button and it didn't do anything. Sounds like
Maybe
no.
it doesn't.
Okay, so I will hand it off to Miro for the next.
Thank you. So yeah, in case for the ones that are not maybe Radius experts already in the room, I will very briefly introduce how Radius works. So in Radius, you have a Radius client and a Radius server, and the protocol, for example, if it's used for authentication, you will have a user that tries to authenticate by sending its, for example, username and password to the Radius client. So that user will not be the Radius client. It will have a third device that it tries to log into the Radius client. And the Radius client then generates an access request that sends this username and an obfuscated password to the Radius server. which will then look up, for example, in a database or through some other way, whether this is the right credentials. And if so, then it will send back an accept to the Radius client, which will then grant the user access to whichever resource it requested access for. And these packets are very often sent over UDP. There is an RFC that specifies how to do Radius over TLS, but it is not a standard yet. And in fact, in practice, most of the traffic is still going over UDP. Next slide, please. So how is this access request looking like? So digging a bit deeper, it starts with a code. 01 here stands for access request. Then it has a 1-byte ID, a 2-byte length field, and every access request can have a bunch of attributes attached to it. There's also a request authenticator, which is just a 16-byte random value. It does not actually authenticate the request, which means that one can modify the request as an adversary without being detected, because this is just a random nonce. The way this Radius is set up is that on the server, in the server config, one specifies an IP address of which clients are allowed to talk to the server. And for this IP address, one specifies a shared secret that is also hard-coded on the client. And this shared secret is then used, for example, for the obfuscation of the password, so that the password is not sent in clear text in, for example, the password attribute here. This is also a bit sketchy construction, but it's not what we break in this attack. Next slide, please. So the other two packet formats that are important for our attack are access accept and access reject packets. Here, note that the code for access accept is 02 and the code for access reject is 03. An accept packet can have a bunch of attributes that are specified for it. For example, to specify on which VLAN a user should be put, or what execution privileges are granted to that user. These responses now actually have an authentication mechanism, that is the response authenticator, which is a MD5 hash over the packet contents that is the target of our attack. Next slide, please. So the goal of this response authenticator is to prevent the forgery of responses, which is necessary because otherwise anyone could impersonate the Radius server and just send access accept for arbitrary authentication requests. And so, for example, for a packet that has the following format: code, ID, length, response authenticator, and attributes, this response authenticator is computed by copying the code, ID, length, and attribute fields into the input of an MD5 hash function. And then it also has the request authenticator, which, remember, is the nonce from the access request in there. And it's appended with a fixed pre-configured shared secret. And this shared secret is what should prevent an adversary from creating a valid hash for a packet that is sent. Next slide, please. Now, in our attack, we managed to produce valid response authenticators without knowing this shared secret, which allows us to inject, or for example, turn an access reject into an access accept. And the way we're doing this is we're going to exploit MD5 collisions such that both the access accept and the access reject produce the same response authenticator. And for doing that, we need to understand the MD5 collisions, for which I give back to Nadia.
Okay, next slide. Okay, so I will go through a brief history of MD5 collisions and the type of collisions that have been developed in the literature. So the earliest weaknesses in MD5 date actually from 1993. This is sort of a pseudo collision. This is a collision of the compression function for MD5. So it was already known very early that that MD5 had some weaknesses, but it was not until 10 years later, in 2004, that the first full MD5 collision was published. And so this collision just produced unstructured strings, which are basically look like nonsense. So I'm calling them G1 and G2 for gibberish. And these have the same MD5 hash. And this means that the MD5 hash function is no longer collision resistant in a cryptographic sense, and so it therefore is inappropriate for use. But this kind of fixed collision is hard to exploit in a realistic context. This does not lead to an immediate attack against protocols. Also in 2004, this attack was able to be extended in a relatively straightforward way to what's called an identical prefix collision. And so the identical prefix collision, you start with, you want to produce two strings, you start with a fixed prefix, and you can produce two strings that are different, that start with that prefix and have the same MD5 hash. So this is also by appending gibberish strings to your prefix, and you have two distinct gibberish strings, and so you have two distinct strings that have the same MD5 hash. This attack takes at most seconds on a laptop now, and this can be used to create, say, colliding PDFs if you want to have colliding PDFs that have the same MD5 hash but have different contents. But this is also not strong enough for what you want to attack a protocol like Radius. Next slide. So the attack that we will actually use is called a chosen prefix collision. And in this case, you can take two distinct prefixes, P1 and P2, and you want to produce two gibberish strings, G1 and G2, so that if you append gibberish string G1 to prefix P1, that will have the same MD5 hash as appending gibberish string G2 to prefix P2. And P1 and P2 can be arbitrary values. And this, because of the structure of MD5, because it uses the Merkle-Damgard constructor, which iterates in blocks to incorporate like an arbitrary length string into the MD5 hash, you can append, once you have a collision at some point in the hash computation, then you could append any fixed suffix string S to both of the colliding strings, and you will still have an MD5 collision. So this is another final property that is useful for the MD5 collision attack. And this is the property that we want to exploit in a real protocol. And this is exactly the attack that was used to produce malicious CA certificates for TLS in 2009, I believe. So the structure there is you can take a certificate, a prefix corresponding to an innocuous looking certificate and a prefix corresponding to a malicious certificate, and then compute these gibberish strings and hide them in some kind of certificate parameter, and then have kind of the finishing suffix for the certificate that you append, and then you get the innocuous looking certificate signed by a certificate authority that still accepts MD5 hashes, and then transfer that signature to your malicious certificate, and now you have a valid signed malicious TLS certificate. So that's how this attack works in the context of TLS. And then, so in the context of Radius, we can try to do the same thing. And so the big question is where you hide the gibberish and how you convince the victim to produce the analog of the signature. So next slide. Okay, so in the context of Radius, the attack looks something like the following. So if we go back to our construction of the response authenticator, then you can produce an MD5 hash that results in the same response authenticator for different packets by starting with a prefix, one corresponding to, say, a proper response packet, and the second corresponding to the response packet that the attacker wishes to forge, and these are highlighted in gray. And these are all values that are known or can be guessed by the attacker. Then the attacker computes an MD5 collision, which involves computing a sequence of gibberish, and then needs to figure out how to stuff this into a Radius protocol attribute that won't cause problems for the victim devices, but will be returned by the server. Then when the server computes the response authenticator, the server will take this whole value, append the shared secret that only the server and the client know, but the attacker does not, compute the response authenticator, send it back, and then the attacker can copy that response authenticator from the valid packet into the one they wish to forge. Okay, so next slide.
Okay, so I'm trying to speed up a bit. Nadia, I think, explained almost all the things on this side already. But so this maybe sounds on the high level a little bit easier than it is, because there are two problems with this approach. One of them is for predicting the prefixes, we need to have the request authenticator and ID that is sent in the access request. So we actually, as an adversary, need to see the access request before we can compute the collision. And the next problem is we need to hide the gibberish in a way that it comes back from the server. So we're looking at these one by one. Next slide, please. So to address the first problem, the attacker needs to be a man-in-the-middle adversary that intercepts the request from the victim client and then learns the request, authenticator reads out the ID, and uses this to predict the prefixes and then compute the MD5 collision. Now, the problem with that is that we need to compute this collision fast enough to be able to respond to the client before the client times out. And so for our proof of concept, we reduced this computation time from many hours down to below 5 minutes. This is still longer than most timeouts in practice. So in practice, you might see up to 30 to 60 seconds timeouts if there are 2 FA involved in the authentication process. And otherwise, it might be lower than that. But the computation is very easily parallelizable. So we think that it can be easily, the time can be easily reduced further if one would spend a few weeks writing a dedicated implementation for this, maybe even on hardware. Next slide, please. Now for the second problem, in order to do this collision, we will need the server to compute the response authenticator, including the rejection gibberish that it needs to be appended for the second collision input. And so why would the server ever do that? That seems a little bit impossible, but fortunately for us, the RFC, or fortunately for the attacker, the RFC specifies the proxy state attribute, which is mandated to be returned by the server without any modifications. And so this is perfect for us. This is perfect for hiding this gibberish. Next slide, please. So the end-to-end attack works as follows. Before we go into more detail, the adversary tries to log into the Radius client, sends a user that he wants to log in as, say, admin, some random password that's certainly wrong. Then it intercepts the access request from the Radius client to the Radius server. It will learn the request authenticator and the ID from that packet, use that to predict the prefixes, and then compute the reject gibberish and accept gibberish for the 2 values of the MD5 collision. It will append the reject gibberish to the access request and send that along to the server. Since that reject gibberish looks like a proxy state attribute, the server will attach it to the response and send back an access reject with this gibberish. The adversary uses the access reject to learn the response authenticator and then puts that response authenticator into an access accept and switches the gibberish out to the accept gibberish, which then creates the same response authenticator and thus validates on the client. And so the Radius client will give the adversary access to this account. Next slide, please. So since we all love bits and bytes, here is a very concrete example of how this works. So the attacker triggers an access request. This request looks as follows. Here we have the ID1D and then a request authenticator that is just some random bytes. The man-in-the-middle attacker puts these 2 values, the ID and the request authenticator, into the prefix, where the difference is just that one of them is an accept and one of them is a reject, as you can see by the starting bytes 02 and 03. And then you can use this to compute collision gibberish. Now, this gibberish can't be fully random because it must look like a proxy state attribute, and so that's why it needs to start with in hex 21. Because that's the number of a proxy state attribute, and then also the right length. And so since our gibberish is longer than what you can fit into a single proxy state attribute, we also need to spread it across multiple proxy states. And that required some improvement of existing MD5 collision attacks. By the way, if you want to actually play around with this example and see the full hex strings, you can look at the example on our website. Next slide, please. So then now that the adversary has this reject gibberish, it can append this to the request, which is exactly the same request as is observed in the first step, and then wait for the server to respond. Since the gibberish looks like proxy state attributes, the response also includes the gibberish. at the very end, but it now has a response authenticator that the server nicely computed for us using the shared secrets that the attacker doesn't know. And so the adversary can take this response authenticator and put it into an access accept and switch out the gibberish, the rejection gibberish to the accept gibberish. Next slide, please. And so this packet will now verify because of the MD5 collision. And so here I wrote out how you would compute the MD5 value. You can look at the script and see that these two values give the same MD5 hash. Next slide, please. I will briefly mention some extensions for our attacks. It is possible to put any attributes into the accept prefix, the access accept packet, so the adversary can give themselves any execution privileges or put themselves on any VLAN that they want to. And this just requires us to pass the predicted access reject prefix. And that is possible with proxy state attributes. Also, proxy state attributes are not the only way that you can create this echoing back. I think this is a mistake on the slide. It should say reject gibberish instead of prefix. Sorry about that. But other attributes could also reflect user input. And so, for example, there could be an application that reflects a username. So it could say in the reject message, oh, sorry, you login for user XYZ failed. And so we could stuff the collision gibberish into the username, and then that would be reflected. And so that could be another way to exploit this attack. And note that the client does not need to interpret these attributes. It just doesn't need to fail. It needs to include them in the response authenticator computation. That's all we need from it. Next slide, please. So in terms of impact, this means that the pub chop and MS chop modes are all vulnerable. The modes that do require a message authenticator attribute are not vulnerable, and this is specifically EAP. The reason for this is that the message authenticator attribute is an HMAC MD5, which is not vulnerable to the MD5 collision attack that we presented here. The threat model does require the adversary to have network access. So if you send your Radius UDP traffic over the open internet, then it's of course broken. But if you have your traffic in a VLAN or use IPsec, then the attacker first would need to have access to this network. But the attack is still very useful for lateral movement within an organization. So if an adversary first got access to your network, it can use this attack to then get access to all the devices in your network that use Radius for authentication. So in the short term, a mitigation is that all requests and responses should include this message authenticator attribute because we cannot break that. But of course, the better solution and the long-term solution is to move to Radius over TLS so that we can wrap Radius inside TLS and we can rely on TLS for the confidentiality and integrity that Radius does not provide. Next slide, please. And I think with that, I hand over to Nadia for the discussion.
Okay, so a brief discussion of MD5. So I think useful for like a meta discussion in the Radius working group is that MD5 has been known to have weaknesses for 30 years. It has been cryptographically broken for 20 years. Sort of until last year, sort of the consensus in the working group appeared to be that there was not an explicit MD5 based attack against the specific construction in Radius, but that was basically due to the lack of cryptographic attention. People did not realize that this protocol was still in use. So it is not that the protocol was secure, it was just that no cryptographer had apparently looked at it. I am very pleased that there is a lot of movement in mitigating this flaw, and it's been great being here and talking to everybody about this, and I would specifically like to praise CERT and Alan for helping with a super complicated coordinated disclosure process, which has been incredibly smooth for such a complex and wide-reaching vulnerability. So the next slide is our last one. And yeah, I think we can, if there's time for questions, happy to.
Hi, Paul Wouters, individual. I'll keep it short. One question I have is if the pre-shared key had been put in first in the MD5 hash, would that have made a difference instead of doing it last?
Yes, yeah.
Yes, it would have made a difference because we couldn't inject the prefix. It matters that we need to be able to inject something before the unknown inputs into MD5, so we could not have created the collision the way we do.
Okay. And my second question was, how much CPU time did you use to get to the 5-minute point?
I let Nadia answer the second question. I just had a thought for the first question too. If you put it first, then you can actually append any attribute to the protocol, to the packet. So that would be a different issue. So it will not be a solution, but.
Oh yeah, right. That would be vulnerable to a length extension attack. So you would have to put it first and last. So if you sandwich it, it's not.
Let's not recommend.
It's not MD5, but or it's not HMAC, but I think it's actually not vulnerable to a collision attack. Okay, or length extension attack. Yeah. So the order of magnitude of the computation is 2 to the 43 hash computations, and so. 64 core hours? Okay, that sounds, yeah.
So sorry, translate this to me in money, like computers in the shop kind of thing.
$50.
Okay, thanks.
Per run or
Huh?
per run, or like that's what your AWS will be for one?
Per run.
AWS calls for one.
Yeah, we did not want to run this on AWS because something that costs $50 per run will cost $10,000 to develop and debug.
So this is Alan. Thank you. It's been a tremendous amount of work. Lots of emails back and forth, as Nadia knows, working through all the issues. Yeah, Hecky from Radiator also helped quite a bit. I'd also say, I think on a protocol design point of view, independent of MD5 or anything else, there are two issues. One is signing data under an attacker's control. As Hecky was saying in the chat, you have a username which gets echoed back. Now you have some kind of injection. The other one is a failure of Postel's law, which is sometimes you shouldn't be liberal in what you accept. Right? If the client sends a packet without proxy state, and proxy state is for certain kinds of signaling, the client should not accept packets which have proxy state. But the RFCs are generally vague about this kind of stuff. Don't worry, it's fine. And I think experience in the last 30 years shows that you might want to be a little more paranoid about what you accept if you can't wrap everything in TLS and go home.
QMySL MPINF, this is I am ignorant about the cryptography question. So you said HMAC MD5 is not vulnerable, but what would be the computational cost of breaking HMAC MD5?
So, okay, so the basis for our statement that HMAC MD5 is not vulnerable is a paper by Mihir Bellare from maybe 10-ish years ago, showing that HMAC is secure. You don't need the assumption of collision resistance for the hash function for HMAC to be secure. It is secure, I think, if it's PRF-like.
Right. Okay.
But there's actually some discussion. There was kind of an enlightening discussion at some point that the output length of MD5 may be an issue because it's only 128 bytes, and so you may be able to, or bits, and you may be able to get a collision in, say, like 2 to the 64 outputs.
So more computationally expensive, but still not great.
Not great if you were thinking future-proof.
Yeah.
Way.
Thanks.
Yeah. So this is HMAC MD5 is not a great long-term solution, but it is something that is implementable now on existing devices.
I'm going to cut the queue after Jonathan just because we're running behind, but Jonathan, go ahead.
Jonathan Hoyland, Cloudflare. So this is super interesting, very cool work. My question is about the long-term mitigation, which is when you run Radius over TLS, is it actually bound to the TLS handshake? Like, does it use the exporter key and actually tie itself to the TLS handshake? Or are you still vulnerable to man in the middle in just like channel synchronization attacks?
Sounds like Alan's going to answer this one.
Yes, we've been having discussions about this on the RADEXT list. The theory is that if you authenticate both sides, TLS should protect you from that. The difficulty is it's not clear how to bind, if it doesn't get, if TLS doesn't protect you, it's not clear how to bind the radius data to the TLS session, because you need to add additional signaling. To a certain extent, the radius client and server, especially for proxies, are just sending packets that they got from somewhere else. So tying it together means you need to inject additional data for hop. I think unlike a lot of other uses of TLS, radius is in a trusted model, which are, you have trust between client and server, which means you are not going to accept TLS connections from random sources. You have to have a client certificate. You have to have a server certificate. And unless the TLS people say otherwise, that should hopefully protect you from issues, unless he argues. In which case
So yeah, so I just want to do the security analysis TLS 1.3, and this is like one of the things that very much annoys me. So let's say I have client connects to TLS server A, and then which happens to be attacker controlled, it hits the wrong server. And then the attacker then goes to the real TLS server B, and they just shuttle the packets in between. That shouldn't work. That should stop working, especially if you inject. So what you're supposed to do is in your MD5 hash, you should take the TLS exporter key out of the TLS session and shove it in the hash, because then it's not valid if it's been forwarded over multiple TLS hops. And that's like, yeah, this is one of the things that's in the appendices that no one reads, and it makes me very sad.
Yeah, I sent that exact statement basically to the mailing list. There's ongoing discussion and disagreement about whether it's necessary. That really is all going to be covered under the DTLS doc, which is our next thing up. So is it, I mean, do people think we should get Jan-Fred to do his presentation and then talk about this? Or do we want to just jump right into this under the rubric, but not make Nadia, and I'm sorry I missed your name, stand up here while we do it.
So I don't think,
please feel free to join in, but it's not about this attack anymore.
so yeah, I'll try and close that in. I don't think the TLS biz discussion will talk about this, because that's all too new. I guess from the protocol point of view, if we can't trust that TLS protects us and we still need to add crypto binding, then all uses of RADSEC today have issues. And we have to add per hop signaling to radius on top of everything else. So when you do that TLS connection, the first thing you get through is some kind of channel binding, crypto binding. We'll need to add that.
I know you were responding, but please try to add yourself to the queue when it makes sense. You know, I added myself to the queue, so I will make my comment, which is that it's not that unusual for things that use TLS to do what I think of as channel binding. You said crypto binding. I think we're talking about exactly the same thing, which would be to take some unique information from the TLS session and bind it into the radius layer processing, so that you know that both ends of the conversation are talking over the same TLS connection. There have been some arguments about why that's not important in radius. I'm being me at this point, not a chair. Okay, I don't buy them yet. The people who made them are really smart, and I might buy them later, but I haven't. I'm not quite as smart as they are, so I haven't figured out why what they're saying is true. If we did want to do it, we have this pesky secret. We decided to overwrite with the word, constant RADSEC. Maybe we could put it there. We do have the notion of attributes. Maybe we could put it there. There are places we could do something to bind these things together. it would be a non-compatible change to RADSEC probably, but definitely, but it's, we could do it. It has some advantages. Whether or not it's worth making a compatibility break with RADSEC is not clear, but we are already making a compatibility break with RADSEC because we're requiring everything that does RADSEC TLS to do RADSEC DTLS, right? So if there were a way to do it where people who don't care what we say is required could keep using RADSEC, maybe that's the right answer. Or if it's actually a concerning attack, we might want to do it before we recommend that RADSEC be universally deployed instead of Radius UDP. And I think we as a work going now, I'll switch my hat and I'll put on my chair hat. Regardless of what my personal opinion is, we as the working group need to develop a consensus opinion on the answer to this question. And I'm would not be sad to find out that I'm wrong, but right now I'm leaning on the side of we probably should be putting in that channel binding. Okay, but my personal opinion is not what's important. What's important is forging a consensus opinion in the working group about this subject. So if people want to talk about this subject, we could talk about it for a few more minutes. We do have the document it's about coming up, but I doubt, I mean, I can't imagine that Jan-Fred has put in a good answer to this problem in slides he probably made before it came up on the mailing list. So does anyone want to say any more about that topic, or should we just keep talking about it on the mailing list? Alan thinks we should keep talking about it on the mailing list. I don't see anybody else expressing an opinion. So let's keep talking about it on the mailing list, because I think I have an opinion and both of us agree. So, so in the meantime, let's get Jan-Fred up to talk about the document and the other issues that exist in the document and what still needs to be done to get this document ready to send to working group last call. Adding, of course, that this new issue also will need to be resolved. So, so Jan-Fred, are you ready to go?
Yeah, I think so. Yeah, so very sorry for the short presentation on that one, because I'm sitting here at a camp and just squeezed in this. Yeah, so I did an update on the document. Go to the next slide. Since the last IETF, we actually had some discussions on the mailing list, and we received finally some reviews. Thanks. I'm sorry for the spelling error. Thanks to all reviewers for their comments. There was really great input there. And Fabian was quite busy putting in a lot of pull requests on the GitHub, where we manage the document text. There are some discussions ongoing in the pull requests, so have a look at that. I think the GitHub repo should be linked on the document page. Next slide. So we have some open questions that one very big question that we should resolve is the question of server identity. We had a very long discussion on the mailing list about that, and I'm not really sure that we reached a consensus or an understanding of what we mean. Because at some point the document talks about connecting to the same server. So we should have some text around that. We have the problem because of the hop-by-hop protocol architecture, that there is a difference between the final destination Radius server and Radius proxy, which then forwards the packet, but for Radius client, it probably looks the same if it's the Radius server or the Radius proxy. So there should be some text around that problem. For some more to-dos, look at the document. I've put them in as comments. So if you use the HTML view, you should have them highlighted. That's what I use to document what in the spec is still not ready. Can go to the next slide. So obviously this slide was prepared before I had time to read all the discussions about channel binding and the TLS PSK selfie attack. And so obviously we would need to address all that. So next steps for now are to include the feedback from the reviews, have a look at the pull requests, sort that one through. And once we're done with that, I think working group last call is a bad idea until we find a solution for all the different problems that we have, because I also have thought of a possible attack that I need to see if it would work, that would probably break some of the assumptions we make, or at least cause denial of service attack probability. So we definitely should have a look at that before we send the document to last call. And we still have some TLS parts where I personally think we could use the input from people who actually know the crypto much better than we do. So I've written Utah here. I don't think it's good for TLS, but maybe some TLS experts are in the room and have opinions on what we're trying to do. Yeah, so the idea that Margaret talked to me about was to have this document ready before Dublin. Would be great if we could manage that, but it would require that we all keep discussing on the mailing list after this meeting, so we can finish up this document. Because also in light of blast radius, I think it's really important that we get a response out quickly and but also not produce another standard that people will throw their hands above their heads and ask what they thought when they were specifying this. And I think that's it from me. Obviously, I didn't have time to include all the discussions on the pull requests Fabian submitted sometime this week. Yeah.
So I'm going to interject here that there are a few things we need to do to get this document out the door. One of them is that we need to enumerate all of the open issues. Right now, some of them are in the document, some of them are in GitHub. I'm not personally sure. I was trying at one point to go through all the email on this document. I'm not sure all of the issues that have been brought up are in the union of those two places. And so the first thing we've got to do, I think, is figure out what are all the open issues on this document, and then obviously resolve them, and then go to working group last call or further. And whether or not that can happen by Dublin is obviously going to depend on how quickly we can do those things. I suggested in the last working group meeting that one of the ways, and Alan has walked out of the room, so we'll see. We don't want to decide anything before he gets back, but one of the ways we could move forward on this is to have like a small design team or a small group of people who are helping you, Jan-Fred, to enumerate all the issues. And there's probably many of the issues in recent emails were what I would consider editorial, and you should just incorporate those without anybody else's opinion. If there's a S missing from the end of a word or something. But for the issues that are not editorial, there are a number of them that are, like one of them is this paragraph should probably occur somewhere else in the document. Okay, and we could just put it somewhere else in the document and send out a version. And if anybody in the working group objects, we'll figure out what to do about it. But, but then there's other issues like the recent ones that have come up around channel binding and there's a few other substantive issues already in the document that I think we're going to need a set of people to propose a fix and send it to the list, because these issues aren't going to get it fixed otherwise. They're not going to get addressed otherwise. And so I don't know that it needs to be a closed design team. I mean, maybe we just want to have a call. I don't know, like a working group interim call to see if we can work on this document with whoever's willing to come. I'm not sure how to get this moving, but we've got to spend some dedicated time working out these issues and writing text as proposed changes. So, and if we can't get that done, the document never gets published, right? So I don't know what anybody here have any other ideas for how we could get some motion on this document? Do you think having an interim call is a good idea? Do you think coming up with a couple other stuckies to help Jan-Fred is a good idea? I mean, any suggestions for how we can get more eyes looking at this and some work going on to actually resolve the stickier issues? People seem excited about the TLS stuff. Maybe if we had an interim call soon, we could have that be one of the agenda items, but we could actually try to cover the issues that have been there longer and people would show up. I don't know. Any thoughts? Because with the current level of feedback we're getting and the current level of text suggestions we're getting, this document will never be published. I will retire and this document will still not be published. So how do we change that?
And I want to add that we are behind the milestone for this document, very badly behind. So we need to move quickly, just to well, the deadline is already passed, but the document is very important. And as a co-chair of UTA, I suggest that Jan-Fred wrote a message to UTA mailing list with preferably with concrete questions, because people are lazy and it's easy to answer some concrete questions and persuade people to review a document.
Yeah, well, I mean, like I just proved, if you write something to the list that you say, I think we should do this, and people don't agree with you, exactly. They will write back. But we need somebody's going to come up with, I think we should fix this problem this way. And then we need to get comments on that text. Yes. Because with no text,
that's what I meant. So just questions and suggestions, and I think it will work. It must work.
So, I think Jonathan was next.
Jonathan Hoyland, Cloudflare. So I was just briefly I haven't been subscribed to RADEXT on my mailing list subscriptions before. But I was just briefly looking through. I think there's some misunderstanding about what channel bindings are and what they're for and how they work in TLS. This is my specialist subject. I'm perfectly happy to contribute now that I know this is happening. And yeah, if you want to have a call, then I'd be happy to join it, assuming it wasn't a ridiculous time. But,
This is Alan. Now that certain panics are done, I have more time to spend on this. Thank you.
Paul Wouters. If you do not get enough reviews about open questions for a document, I just recommend that the author puts in what they think is best, and then you hit the early review buttons, and then at least you get some feedback from other people. And you can do that as at least a kickstart of the process.
So for me personally, I think it would be nice to have at least a few people set up a call. I don't know if it should be an interim or just an informal call, not directly connected to the RADEXT working group, just so that I'm not the only person looking at this stuff, because of course I have the EduRoam view, but only that one. So it would be nice to have other people who have a different radius point of view in there too, to help me figuring out what the best course of action would be.
Maybe we can rope in Valerie and Jonathan to get some TLS experts on the call too.
Sorry, Paul Wouters, speaking as AD. If you do a meeting like that, I would recommend you do use the Meet Echo tools and the official interim facilities, because then there's a recording of it. People can look at it later, can come back with feedback. Usually the biggest problem for interim meetings is that you get too many people showing up and you don't get any work done. But honestly, this is Radius, it's not your problem.
Yeah, I mean, I think we will, I think an interim meeting would be better and more open because it'll be advertised more widely and stuff. But I think that's a detail. I think if Jan Fred is saying he would like to have some open discussion of this, it'd be pretty easy for us to set up an interim unless you would object, which I can't imagine.
Sounds very good.
Okay, so what's up after this one? It's gonna be you. I have the agenda here somewhere. There we are. Deprecating insecure practices.
Yes, so this is the second or third attempt for me to fix Radius. 5080 was first. That was only 2007 or something, so we're fine. Next slide, please. So the blast radius attack means there's a whole lot more content in the document, description of the attack, mitigations. There's almost 10 pages new content with lots of details. In theory, everyone has to upgrade everything unless they don't care, in which case it's fine, we're vulnerable, we don't need to change anything. That is about half of the responses we've been getting for this, unfortunately. Next slide, please. So for people who missed SAG yesterday, Radius was defined in 91 by Livingston. What I don't have on here is fights between Jeff Schiller and Mike Odell from UUNet in 95, where Jeff Schiller hated MD5 and then ran away because he just didn't want to deal with it. And so Radius got published. 97, there was the actual first draft published. 98, the HMAC auth starts being defined, and 98 is the first record I can find where I complained about this insecurity. So it's been a while, and then 2869 says, yeah, we don't need to authenticate packets, it's fine. After a bunch of discussion on the list about it. In 2007, I'm the co-author on 5080, which was, can we just use HMAC everywhere? And the suggestion was to always include HMAC on every access request being sent out. And so far as I know, there was only one implementation that did that. And then now we're getting hit over the head in 2024 with a frying pan for things that we should have fixed 20 years ago or 30 years ago. Next slide, please. Yeah, does anyone still use Radius? I thought it got replaced by Diameter, or maybe we could use EAP-TLS, but no one's actually using PAP-CHAP, MS-CHAP over UDP, right? Except for cloud providers who say they're using Radius UDP over the internet, and that people should use MS-CHAP because it's more secure than PAP. And this is the marketing text that people have on their websites. And it's wrong. MS-CHAP is effectively clear text at this point. If you're willing to use a little bit of disk space and about 10 milliseconds of work, you can invert MS-CHAP and get the passwords out. So it's a disaster. Maybe we can use TACACS in some cases for administrator authentication. People are already using that. There is a Radius RFC for admin authentication and authorization, which so far as I know, nobody has ever implemented. And then the other pushback is the attack is hard, so I don't need to upgrade. I was just looking earlier today on GitHub. There are FPGA code for MD5. So if you're willing to throw that into an FPGA, you might be able to get another 2 orders of magnitude performance improvement, depending on what else you can do with it. Next slide, please. So the original intent of this document was, hey, an attack is coming, which was a little timely perhaps. Maybe we should just deprecate UDP. And then as various other things came up, including the attack, there's a whole list of deprecating other things too. We should consider MS CHAP to be 100% broken. There's a lot of text on PAP versus CHAP. There's a lot of recommendations out there saying PAP is insecure, use CHAP because it's not sending clear text over the wire, which PAP isn't either, but nobody pays attention to that. And if you use CHAP, you now have to have all of your passwords in clear text in the database. And for anyone who's seen any pwn to own things, that's a much worse problem than your password being sent maybe in clear text over a DSL PPPoE link. Unfortunately, most public recommendations are horrifically wrong, which is why I think it's a good idea to wedge whatever we can into this so we can point at it and go, this is the right way to do things. Next slide, please. Yeah, some last minute notes. There are no RFCs which recommend delaying access rejects. Otherwise, you can do dictionary attacks. There have been people, most notably Apple years ago, got attacked by this. You just send billions of requests and you can guess people's passwords. So this needs to be added to the document. And nothing recommends constant time comparisons for things like the request authenticator, response authenticator, message authenticator, that kind of thing. And then also based on Bernard's comment on the list, there are security issues with Radius. Once you are within that trust framework, you can do anything. So there is no provisions anywhere, not even any discussions anywhere on I just invent packets for someone else's realm and I can send disconnect or COA packets somewhere else. I can invent accounting packets, send them upstream. There's all kinds of attacks you can do once you're in that trust framework. Typically, these are stopped by the administrators phoning each other and saying, stop doing that, but it's worth mentioning. Next slide, please. I think that's it, other than, yeah, nobody's looked at Radius security for 25 years, so it's a nice change. Another 30 years. Oh gosh. Yeah. Questions, comments, stones? No? Everyone's happy? I think everyone's tired out from previous discussions on radio security. I think that's it.
Yeah, I mean, I think we need to get the thing in shape that we're telling everyone to move to. And that's the tricky part right now, is we're telling everyone to move to something we know from the work we're doing on that document is incomplete, and we wonder if it's secure. So that we need to have a lot more certainty about that. I think this document is blocking on the previous document we talked about. So it's going to be published after the one that will never be published unless we do work on it. Yes, you are. As usual.
ALPN. Yes, next slide, please. So this started off as Radius 1.1, turns out it ends up being getting rid of MD5 completely and relying on TLS completely for security, which helps with FIPS, among many other things. Lots of reviews from lots of different people, lots of different typos. Barring any additional issues like channel binding, crypto binding, the document is implemented. It seems to be done It's interoperable. People are happy with it. And it does solve other long-standing issues with Radius, like you can send more than 256 packets over a TCP connection. Everyone's happy with that?
I mean, we're gonna have to get more review on this document. I think right now we're gonna focus on the other one, but I don't know that
I think-
anyone's unhappy with this document, but I also don't know that enough
I
people have
think the
read it.
document is waiting for our ID, for Paul. At least it is indicated in the data tracker. So if Paul is in the room,
So
I
Paul
have-
is AD reviewing it at this point?
yes, that's what the data tracker said. Submitted for to ISG for publication. Action holder Paul Waters.
So I've complained about the action holder marker and the data tracker, because if there's any kind of AD follow-up happening, the action remains physically on us, but it's actually on somebody else to do the work. So let me just, while you continue, I'll check exactly what the status is and why this is waiting. I'm hoping it's not waiting on me, but if it is, then I'll fix that soon too.
Okay, thank you.
But, okay, next one is TLS PSK.
So TLS PSK, next slide, please. Minor changes since IETF 119, some PR from Hecky. I've been somewhat busy, haven't updated the document. It seems to be pretty close, barring some additional comments from Bernard in the last week. It's good to put additional text in about checking identities and PSKs and all that. Because if you have the PSK, you can pretend to be client or server. And so that needs to be made a little bit more explicit in the document. Fabian implemented this in RADSEC proxy. Me and my team have been busy. We haven't done it in FreeRadius, but after some squinting at OpenSSL, it does seem to work. And I believe you can do TLS PSK and or client certs in the same system at the same time, which helps with flexibility of configuration. So you're not forced to do one or the other. Next slide. I think that's it.
It's the last slide.
Zero.
And
Good. Okay.
yes, and this document is also sent to ISG, but as data tracker indicates, it needs to be updated after ID review. So Alan, if you have time to make this update, and then Paul hopefully will move this draft further.
Well, it sounds like we have a D review, but also a PR from Hecky. So okay, but I think we need a new version of the document out, and we need, people in the working group to at least be given a chance to read it if they're, and then we can, at the same time, ask Paul if it addresses his concerns.
So we're through with publications. Some open mic. Jan-Fred?
Yeah, so just in response to the TLS PSK and the selfie attack, I think it would be very useful to actually have a close look at that one. I haven't had the time to read it fully because I'm here at a camp, but it looks like setups like EduRoam would possibly be affected by that, because they usually have a setup where the Radius proxy is acting as both Radius client and Radius server. So if I understood the attack correctly, those clients would be, or those peers would be vulnerable to that attack. So I'm not exactly sure how the process would be now that the document is actually already submitted to IESG, but definitely I will have a look at that one and maybe produce some text.
From a process standpoint, if we find a technically blocking problem with a document, it doesn't, I mean, there's no problem with us saying to Paul, never mind, and moving it back into the working group to fix it. I don't, it's not going to go through the ISG without somebody figuring out for sure if this is vulnerable to the selfie attack and what we have to do to make sure that it's not. Hannes, who I don't think is here, sent some, I can't say his last name, Chauffenet, something like that. I've known him for like 30 years and I can't say his last name, but if he sent some stuff to the list about what would be needed to make it not vulnerable, obviously it would be good if some other people look at that. I assume TLS people have already trodden all over the selfie attack thing, and then we probably want them to look at what we've written and see if it makes sense.
So yeah, I wrote an RC 9257, which is directly addressing this and like how to fix the selfie attack and all the things you need to do to make sure selfie doesn't happen in this case. So yeah, 9257.
Yeah, I think that was referenced in Hannes's reply. Fabian?
Yeah, in short, the way I read selfie is basically don't accept your own identity for incoming connections. So
Palo Alto City, I just had a look at the V11 document. It's basically ready for me to initiate the ballot for the ISG, so it should be on the telechat in the next couple of weeks.
Well, that would be cool, a little progress. So it's open mic time, so if people have open mic issues, please step up and, Sri.
Yeah, Shri Gandavelli, Cisco. So we had one submission on the 5G authentication or radius. So last IETF I presented and the feedback from the working group was at the time that we are too busy. We need to clear a few things. I'm just wondering when is it a good time to bring some new work?
I'm not inclined to ask Paul to let us do new work until we get the DTLS document out. Is Paul inclined to tell me I should consider it sooner than that?
Paul Artis. It's really up to you, or up to the chairs. If you think the working group can sort of do this on one end and also start thinking of new work. Normally the problem is that new work takes over everything and nobody works on the older work. But again, if we looked at the room here before, the older work is not getting reviews anyway, so that's not your problem here in Radius. If you want to do that, sometimes I hold back a recharging to make people work on the older things, but I think here people really do want to work on it. That's just a matter of reaching out to the right people. So I don't have any principled issues of, slowly ramping up new work, and we can do the rechartering.
Right. Well, I mean, one of the questions I guess we could put to the group is, has anyone who here has read the document that Shri is talking about? And Shri, could you come up and make it clear what document, just so that people know if they've read it? I have read it, but.
Yeah, this is for supporting in the private 5G environments. Today, if you look at cellular architecture, support only SIM-based authentication. That's our diameter interfaces. So in P5G, private 5G is getting deployed in enterprise environments. Enterprises use Radius infrastructure extensively for all the Wi-Fi access authentication on .1x Ethernet devices. Now, In that environment, if you bring in a P5G device, we don't need a new authentication infrastructure. We can use the same radius infrastructure for authenticating SIM and non-SIM devices. So the proposal is about defining a new method that supports a 5G ACA method. So that enterprise can use one infra for policy and identity correlation, everything is in one place.
I may have old information, but last I knew we had a liaison relationship with this is the 3GPP partnership, right? No?
This is not exactly, we are not touching the 3GPP architecture. I think all we are saying is if some enterprise deploys P5G, they can potentially use, this how it can work. These are the elements that they can send signal in the access request. This is how the algorithm works. This is how the authentication is enabled. So we are not truly, we don't have to go to 3GPP, but I think that's my view. Yeah.
Yeah, I mean, we should make sure the 3GPP thinks we don't have to go to them too. But let's, has anyone in this room read this document besides me and Sri? Helen has read it. How about how do I ask that on the participant list? Is there a way to ask people, like if they've read something, we can poll, right? I don't think I can do that from here. Do you know how to do a poll from your side, Valerie?
I will do it. What's the question do you want to ask? Do you read?
Who on the call
who won't work?
Whether you read. Have you read the 5GP, is it?
Draft Gundavalli, RADEXT.
Draft Gundavalli, RADEXT.
X5G auth, 01. Yeah.
What did you say? X5G?
I'm not sure I will
RADEXT.
spell it correctly. Okay, but I think people understand.
No opinion. No one has said no opinion. It's funny to think what that might mean.
I think perhaps this should be reminded on the list, the problem statement and the solution, just for people to bring attention of the people, because it seems that currently almost nobody reads this draft yet.
Yeah, so I think we should go on the list and we should ask people to read the list, read the draft and express opinions about whether they would like to bring it into the working group, including a well-formed message like, would you be willing to work on this draft? Would you be willing to review it? Are you planning to implement it? That sort of thing.
Sure.
And see what response we get.
Like
not a BOF, but kind of the BOF questions. And if the working group is interested in working on the document, then we'll go to Paul and talk about how we get that out to new work and whether going to new work is good enough to get the 3GPP's opinion or whether we need to go through the liaison. And then if everybody wants it, maybe by then we will have made some progress on the STTLS stuff. We'll have to see about the timing of bringing it in. If this group isn't going to have interest or anything to read it and actually move it forward in a useful working group way, I mean, there are other possible channels like trying to talk to Paul about whether he would AD sponsor it or something, and have us do a review, the 3 or 5 people who've read it, but I don't want to bring it into the working group if we don't have enough interest in the working group to actually reach working group consensus in a meaningful way on publishing it, because otherwise that's kind of just a waste of time. So let's see we'll send a message and see if the group replies
Yeah, just
with interest.
one comment is last time when I presented, I thought at least from my notes says there was good amount of interest. That's the only thing I can say.
And Sri, I suggest that you not only send a message, just a short message, just with the suggestions for the people to read the draft, but send along the message which describes the problem and summarize the way you are going to solve it, because people, before they read the draft, they understand what it's all about.
Sure, I'll do that. Thank you so much.
Paul Wouters. Yeah, if this is specifically related to to SIM card verification or something, did I understand that properly? Okay, so then I would definitely want to make sure that those people that do SIM cards actually know about this and that this is something they want, right? Like we shouldn't make standards here that the people who actually are supposed to use them don't know about.
Yeah.
QMySol MPI inf. Hopefully this is an easy question. Why is this implemented as an extension of Radius and not as an EAP method?
I'm trying to understand your question. Yeah, 5G ARCA is a method that's widely used, right? So EAP is another mechanisms. What you're suggesting is EAP is not so extensively used in the cellular device at this time. 5G ARCA, I meant to say 5G ARCA. EPS ARCA in 4G, 5G ARCA and this thing. There's also EAP based infra, right? So yeah.
Yeah, there's a whole 3GPP architecture into which what Sri is talking about fits. And I think what he's saying is they're trying to do this as a small extension to the existing 3G architecture, not to move the 3G architecture to EAP, which maybe it would have been a good idea if they used EAP or something in the beginning, but there's a separate SIM authentication method in Radius that was done that way and not through EAP.
Yes,
historically.
Right, so there's a fundamental difference between EAP ACA and 5G ACA, which I'm failing to understand. Cool.
Anybody else have anything? No, I think we can end early and get, I don't know, 38 minutes of our life back. Thank you, everybody. And watch the mailing list for a message from Sri starting out with asking people to read it and writing a short explanation of it. And then, a couple weeks after that or a week after that or whatever makes sense, the chairs will send a message to, maybe we'll write back and tell people what was discussed in this room. But then we'll send a sort of a solicitation of interest kind of message to see if there's enough. So we don't have, at least 5 or 10 people who want to read it and think this group would be the right place to move it forward, then I don't, I don't think we can. If we do, then we'll talk to Paul about how to do that.
Sure, thanks.
So that is done.
So thanks to everybody.
Sorry, the mic is still hot.
See you on the
Valerie.
mailing list.
Thank you, Valerie.
See you.
We'll talk about the alt QR draft for IPsec too, Valerie. I just saw the messages, but I haven't been able to read yet what Tara was whining about.
Okay.
Alan has really baked him, so I have to go.